Have you ever wondered what happens when stars collide? This is not a question of poetic speculation, but a scientific curiosity that has puzzled astronomers for centuries. When two celestial bodies in the vast expanse of the cosmos defy their solitary paths to cross each other, we witness a stellar collision. This cosmic spectacle is an event of immense magnitude, and it's a phenomenon that, even today, remains not fully understood by scientists. Stellar collisions are an intricate dance of gravity, energy, and light, a breathtaking ballet of destruction and creation on a cosmic scale. There's a certain enigma surrounding these celestial events, a mystery that stems from their rarity and the vast array of factors that contribute to their occurrence. You see, any stars in the universe can collide, whether they are alive, with fusion still active, or dead, with fusion no longer taking place. The players in this grand performance can range from white dwarf stars, neutron stars, black holes, main sequence stars, giant stars, to supergiants. Each of these stars is unique in its type, mass, temperature, and radius, and so they react differently when they collide. What makes these stellar collisions so fascinating yet elusive is the rarity. In the globular clusters of our galaxy, events of this type are predicted to occur only about once every 10,000 years. Imagine that! A spectacle so rare that it happens only once in 10 millennia. And yet, despite their rarity, the impact of these stellar collisions extends far beyond the immediate spectacle. They serve as catalysts for cosmic change, their aftermath reshaping the celestial landscape and altering the course of stellar evolution. Yet, as we delve deeper into the cosmos, we're only beginning to scratch the surface of understanding these celestial phenomena. The complexity of stellar dynamics, the mechanisms of binary stars, and the mysteries of gravitational radiation all play a part in this grand cosmic ballet. A celestial dance of destruction and creation, stellar collisions remain one of the universe's most breathtaking mysteries. The stellar enigma continues to captivate us, beckoning us to look up, wonder, and continue our quest for understanding the cosmos. Rewind to the 2nd of September 2008, when scientists first observed a stellar merger in Scorpius, named V1309 Scorpii. This event was a cosmic ballet, a dance of two stars spiraling closer and closer until they eventually became one. A dance that took place over millions of years, but for us, it was a moment in time, a blink in the vast expanse of the universe. At the time, the significance of this event was not fully understood. The cosmic event was observed, recorded, and noted, but it was not immediately recognized as a stellar collision. The star's dance was so subtle and graceful that it was easy to overlook its true nature. What was happening in reality was a process that's as violent as it is beautiful. Two stars caught in each other's gravitational pull, spiraling closer and closer until they eventually collide and merge. A stellar merger. The energy released in such an event is colossal, lighting up the cosmos in a brilliant display of cosmic fireworks. V1309 Scorpii was not just any stellar merger, it was special because it was the first time we'd ever witnessed such a phenomenon. Prior to this, stellar collisions were purely theoretical, something that existed only in the complex mathematical models of astrophysicists. But V1309 Scorpii changed all that. It made the abstract concrete, the theoretical practical. It was proof that stellar collisions are not just a possibility, but a reality. The discovery of V1309 Scorpii was a monumental moment in astronomy. It opened up a new window into the universe, a new way of understanding the cosmos. It showed us that stars are not static but dynamic. They are born, they live, and they die. And sometimes in their death they give birth to something new, something extraordinary. V1309 Scorpii was a cosmic spectacle, a testament to the universe's constant state of change and evolution. It was a reminder that we are part of something much bigger than ourselves, something awe-inspiring and humbling. A historical event in astronomy, it was the first time humanity had a front-row seat to this cosmic spectacle. But what happens when these celestial bodies collide, you may ask? Well, the outcomes of stellar collisions are as spectacular as they are cataclysmic, birthing phenomena that are as beautiful as they are violent. Let's begin with a type of stellar explosion known as a type Ia supernova. This occurs when a white dwarf, the remnants of a low-mass star, forms a binary system with another star. The white dwarf begins to draw material from the other star, forming an accretion disk. On rare occasions, two white dwarfs orbit each other so closely that their gravitational waves cause them to spiral inward towards each other. This intense dance continues until they merge. If their combined mass approaches or exceeds a certain limit, known as the Chandrasekhar limit, carbon fusion is ignited, raising the temperature to unimaginable levels. The white dwarf, being made of degenerate matter, has no equilibrium between thermal pressure and the weight of the overlying layers of the star. This leads to runaway fusion reactions that rapidly heat up the interior of the combined star and spread, causing a supernova explosion. The result? In a matter of seconds, all of the white dwarf's mass is thrown into space. Similarly cataclysmic are neutron star mergers. When two neutron stars orbit each other closely, they too spiral inward due to gravitational radiation. Upon merging, their union gives birth to either a heavier neutron star or a black hole, depending on whether the mass of the remnant exceeds a certain limit. This process creates a magnetic field trillions of times stronger than Earth's. Astronomers believe that these types of events are what create short gamma-ray bursts and kilonovae. These cataclysmic consequences of stellar collisions are more than just cosmic fireworks. They are key events that shape the universe, leading to the formation of heavier neutron stars and even black holes, the most mysterious entities in the cosmos. In a matter of seconds, all of the white dwarf's mass is thrown into space, a cosmic cataclysm that shapes the universe as we know it. Fast forward to the 25th of August, 2017, a date that marked another milestone in our understanding of stellar collisions. This was the day when the gravitational wave event, GW170817, made its cosmic debut, a monumental occurrence that would further enrich our knowledge of the universe's most incredible phenomena. The event was associated with the merging of two neutron stars, those ultra-dense remnants of massive stars that have exploded and died in a galaxy far, far away. What made this event particularly groundbreaking was that it was the first time such a merger was observed via gravitational radiation, a concept proposed by Albert Einstein over a century ago. Gravitational waves are ripples in the fabric of space-time, generated by some of the most violent and energetic processes in the universe. And this time, these ripples were caused by two neutron stars, each probably about the size of a city, but with a mass greater than our Sun, spiraling closer and closer until they eventually merged. Now imagine two objects of such incredible density, each with a gravitational pull billions of times stronger than Earth's, spinning around each other at an unimaginable speed. As they do so, they create ripples in space-time, like a stone thrown into a pond. These ripples, these gravitational waves, travel across the universe at the speed of light, carrying with them information about their cataclysmic origins. The detection of this event was a triumph for astrophysics. It confirmed once again Einstein's theory of general relativity and provided us with valuable insights into the life and death of stars, the properties of extremely dense matter, and the expansion rate of the universe. It also opened a new window into the universe, a new way of observing and understanding the cosmos. And thus, the universe revealed another secret, another piece of the cosmic puzzle. So, what can we learn from these cosmic collisions? From the enigmatic nature of stellar collisions to our first witnessed collision, we've embarked on a journey across the universe, witnessing the cataclysmic consequences of these events. Each collision, whether it's between two main sequence stars or the gravitational dance of two neutron stars, offers us a glimpse into the intricate laws that govern our universe. These celestial phenomena, though rare and often happening once every 10,000 years in our galaxy's globular clusters, provide us with valuable insights. They enable us to understand the life cycle of stars, from their birth in nebulae to their death as white dwarfs, neutron stars, or black holes. The curious case of V1309 Scorpii, the first observed stellar merger, underscores how our understanding of the universe is constantly evolving. What was once a mysterious light in Scorpius is now a testament to the immense forces at play in the cosmos. Moreover, the cataclysmic results of these collisions, from supernovae to gamma-ray bursts, showcase the immense energy and matter involved in these events. This understanding is crucial as it helps us comprehend the scale and magnitude of the universe that surrounds us. The gravitational wave event GW170817, the first observed merger of two neutron stars, was a groundbreaking discovery. It not only confirmed theories about gravitational waves, but also shed light on the creation of heavy elements in the universe, further enriching our understanding of the cosmos. These stellar collisions also have profound implications for our understanding of physics. They challenge and refine our understanding of gravity, mass, temperature, and even the very fabric of space and time. In essence, these cosmic events are not just spectacular phenomena. They are cosmic laboratories, providing us with the opportunity to observe and understand the universe in ways that would otherwise be impossible from our tiny corner of the cosmos. As we continue to explore the cosmos, each stellar collision brings us one step closer to unraveling the mysteries of the universe.